Hello students, let us continue chapter 10, gravitation. In last video, we have discussed about thrust and pressure. So today, let us start with an example regarding with this thrust and pressure. Example number 10.6. A block of wood is kept on a tabletop. The mass of wooden block is around 5 kg and its dimensions are 40 cm cross 20 cm cross 10 cm. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimensions first 20 cm cross 10 cm and second 40 cm cross 20 cm. So let us start the solution. Here the mass of the wooden block is given, that is 5 kg, and the dimensions are also given 40 cm cross 20 cm cross 10 cm. Here the weight of the wooden block applies a thrust on the tabletop. Just we have discussed in last video. Thrust will be equal to F is equal to M into G. M is the mass of the block and G is the acceleration due to gravity on the earth, that is 9.8 meter per second square. So 5 kg into 9.8 will give 49 Newton. And area of the side, length into breadth, that is 20 centimeter into 10 centimeter, and we'll get 200 centimeter square. But we have to find out the answer in meter square, therefore 0.02 meter square. Now by applying the formula pressure is equal to thrust upon area, we will get here the thrust is 49 Newton while we have find out the area 0.02 meter square. So on dividing 49 by 0.02 we will get 2450 Newton per meter square. Again for the second case, when the block lies on its side of dimensions 40 cm cross 20 cm, it exerts the same thrust. Now for second case, area is length into breadth, that is 40 cm cross 20 cm, that is 800 cm square. But we have to find out the answer in meter square, so it will be 0.08 meter square. And again on applying the pressure formula, pressure is equal to thrust upon area, we will have 49 Newton upon 0.08 meter square, this time the second case. And on solving this we will get the answer 612.5 Newton per meter square. The pressure exerted by the side 20 cm cross 10 cm is 2450 Newton per meter square, and by the side 40 cm cross 20 cm is 612.5 Newton per meter square. Therefore, the same force acting on a smaller area exerts a large pressure and a smaller pressure on a larger area. This is the reason why a nail has pointed tips, or knives have sharp edges, and buildings have wide foundations. Now the next topic, pressure in fluids. All liquids and gases are fluids. A solid exerts pressure on the surface due to its weight. Similarly, fluids have weight and they also exert pressure on the same base and walls of the container in which they are enclosed. So we can say pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. Or we can say the liquids and gases are fluids. Pressure exerted by any confined mass of fluid is transmitted undiminished in all the directions. Now the next topic will be buoyancy. So let us discuss. To understand the concept of buoyancy, let us have an example. Have you ever had a swim in a pool and felt lighter? Yes, of course. Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and steel does not sink in seawater, but while the same amount of iron and steel in the form of a sheet would sink? These questions can be answered by taking buoyancy in consideration. So let us understand the meaning of buoyancy by doing activity. Activity 10.4. So here take an empty plastic bottle. Close the mouth of the bottle with an airtight stopper. Put it in a bucket filled with water. The bottle floats definitely. Now, push the bottle into the water. You feel an upward push. Try to push it further down. You will find it is difficult to push deeper and deeper. Water exerts a force on the bottle in upward direction. Now release the bottle, it bounces back to the surface. So, why it is happening? Actually, it is due to the buoyant forces. Does the force due to gravitational attraction of the earth act on this bottle? If so, why doesn't the bottle stay immersed in water after it is released? Yes, here the force due to the gravitational attraction of the earth acts on the bottle, but in the downward direction. And here the upward force exerted by the water on the bottle is greater than the downward force mg, and hence the bottle does not stay immersed in water. This is the buoyant force, but floats. Now, can you immerse the bottle in water? Then yes, if downward force mg is greater than the upward force of water, then the bottle will definitely sink. If we fill the bottle with sand and put it in the water, it will sink. Here mg is greater than the upward force of water. Now next concept, why objects float or sink when placed on the surface of water? To discuss this, let us have two activities, activity 10.5 and activity 10.6. So in activity 10.5, take a beaker filled with water. Take an iron nail and place it on the surface of the water and observe what happens. Yes, definitely in observation the nail will sink. Now in activity 10.6, take a beaker filled with water, take a piece of cork and an iron nail of equal mass. Place them on the surface of water. Observe what happens. Here the cork floats and the nail sinks. Why? The density of cork is less than that of water. So the upthrust of water on the cork is greater than the weight of the cork, and the density of iron is more than that of water. So the upthrust of water on the nail is less than the weight of the nail. Next, very important concept, Archimedes principle. To understand Archimedes principle, let us have an activity 10.7. Take a piece of stone and tie it to one end of a rubber string, as shown in the figure. Suspend the stone by holding the string. Note the elongation of the string. Now, slowly dip the stone in water in a container, as shown in the figure. Here, observe what happens to the elongation to the string. And our observation will be the elongation of string in case B, second figure, is less than that in case A, the first figure. Here, the elongation of string decreases when the stone is dipped in the water due to the upward force exerted by water on the stone. So, what is Archimedes principle? When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. And here the application of these Archimedes principle in designing ships and submarines. Lactometers used to determine the purity of a sample of milk, or a hydrometer used to determine the density of liquids. All these are applications of Archimedes principle. Now let us again discuss about the buoyant forces. So here in this experiment, what we have observed, the elongation produced in the string or the spring balance is due to the weight of the stone. Since the extension decreases once the stone is lowered in the water, it means that some force acts on the stone in upward direction. So as a result, the net force on the string decreases and hence the elongation also decreases. As discussed earlier, this upward force exerted by water is known as the force of buoyancy. The last concept of this chapter, relative density. As we know that the density of a substance is defined as mass per unit volume. The unit of density is kilogram per meter cube. The density of a given substance under specified conditions remains the same. Therefore, the density of a substance is one of its characteristic properties. It is different for different substances. For example, the density of gold is 19,300 kilogram per meter cube, while that of the water is 1000 kilogram per meter cube. The density of a given sample of a substance can help us to determine its purity. It is often convenient to express density of a substance in comparison with that of water. The relative density of a substance is the ratio of its density to that of water. So we can write the formula: relative density is equal to density of a substance upon density of water, only with respect to water, since the relative density is the ratio of simple quantities. It has no unit. So students, we have completed this chapter here. I hope you understood all the concepts of this chapter, like gravitation, gravitational force, pressure, thrust, buoyancy, etc. All the concepts clearly. Thank you for listening.